So up here, as long as something is a function, this diagonal symmetry works. So these are both what we call non-linear inverses. And so as you can see here, this is just f of x equals x squared. You guys are familiar with the quadratic equation. And then if we do some, go through that process of finding the inverse function, we'll end up with x equals y squared. And if you were to graph it, it looks like this. Now over here, I have an interesting function. In blue, I have f of x is equal to x cubed, and then the inverse of that would be the cube root of x. And so if you look at x cubed, the cubic kind of does this thing, and then the inverse function does the same thing. But what I want you really to take away is that the blue one is the mirror image of the red one. I should say the red one is the mirror image of the blue one, and same thing over here across this diagonal line. There's symmetry across y equals x. So let's jot that down too. Symmetry across y equals x. And Mr. Adams will always say the diagonal. It's just, and it's not my choice. I think every math teacher that I learned this stuff from, they always called it the diagonal, because we use this a lot. It's just y equals x, okay? Especially when it comes to inverse functions. All right. So what I'd like to do for example number 3, and we already know how this is going to look, but I want to go through the process and determine some things and see how the graph looks, okay? So how do we do this process? Well, again, right down over here, when we find the inverse, so to find inverses, first step, we're going to take f of x and we're going to replace that with y, right? You're just going to put a y in. I wonder if I should do it this way. I wonder if we should put, I'm going to plug in y for f of x. Now the other way is probably better, but you get the gist of it, right? Step 2, what we do is we solve for x equals some stuff. Okay? Step 3 would be swap x and y for would be, I'll just write it out, replace y with the f inverse notation. Okay? So let's go over that again. To find the inverse, the first thing I'm going to do is I'm going to plug in y for f of x. Next thing I'm going to do is solve for x equals some stuff. Then I'm going to flip-flop or swap the x and y's. Wherever there's an x, I plug in a y. Wherever there's a y, I plug in an x. Last step, we're going to get y equals something. So we're going to replace that y with the f inverse notation, and that's pronounced f inverse. Where's your ID? Okay, well, hang it around your neck. So let's do that. So I have f of x is equal to x squared. And another thing, read the directions really carefully. So let's find the inverse of this, but there is a domain restriction. Okay? Then graph the function and its inverse. So when I'm done with this thing, because they told us, now we look for domain restrictions that happen, but also we can be told a domain restriction. So they're telling us the domain is restricted to x's greater than or equal to 0. So the first step, replace f of x with y. Then we have to solve for x. So first step, f of x, replace with y. Second step, solve for x. That means I got to get x equals some stuff. Right now I have y equals x squared. How do I get rid of the square? It's raised to the second power. How do I get rid of the power? What's the inverse operation of a power? Yeah, everybody's kind of going root. So I'm going to take the square root. Remember, whatever I do on one side, I have to do to the other. Also remember that we have to think about the positive and negative. So whenever we take the square root, there's that positive and negative introduced. But really, it's going to be on the other side. Because over here, I'm just going to get x squared. And when I take the square root, it just becomes x. But over here, I have to think about plus or minus y. Or the square root of y, I should say. So that's done. We've solved for x. Now we swap the x and y, so I'm just going to write that over here. I'm going to say y equals plus or minus the square root of x. So I changed a couple things. Wherever there was an x, I put a y. Wherever there was y, I put an x. And then I kind of flip-flopped the order, so the y was on the left-hand side. But that's okay. You can do that. Well, that's done. Pretty easy. Lastly, we're going to replace the y with the f inverse notation. Plus or minus the square root of x. So originally, the domain on the actual function, this is the domain, right? This is the domain of our function f. And that's restricted. But now, when we talk about how does that restriction play out on the inverse? Well, f inverse's domain isn't necessarily was restricted because x has to be greater than or equal to 0. But remember, the domain of f is the range of the inverse, right? So then my range has to be positive. Because I'm going to take this, which is the domain of f, and then for f inverse, because the domain and the range get flip-flopped, I'm going to do this. So what does that mean? Well, that means that I ignore the negative root. So then f inverse of x is equal to just the square root of x, the positive one. Okay? because the range has to be positive. So this has to be positive. If I put a negative sign here, I'll have all negative numbers, and I can't have a negative range. All right, so lastly, we're going to try to graph this thing. So this is kind of like a piecewise function, so go to y equals. I'll show you how to do this. And hopefully Mr. Adams can remember how to do this. So I'm gonna graph f of x. I think you do x squared. We got to put the domain restriction. So you have to put it in parentheses. And then right next to that, I'm going to put another set of parentheses. Okay. Then I'm going to type in x. And then you go to math. And see the word above math where it says test? See that word where it says test? I'm going to hit second test. And it has to be, remember we said x had to be greater than or equal to 0. So I'm going to put that in there. And then I'm going to put in 0. And then I'm going to hit graph, and I hope that I did it right, because that should just, yep. Oh, it doesn't do it, though. It does, but it doesn't. Okay. And then on the other side, if I hit y equals, I could just put the square root, the positive square root of x. And then we go back and we look at the graph. And so what we're really interested in is just this. The calculator does some wonky stuff over here, but you could see that this is the mirror image of this. So I'm just going to take the picture. Mr. Adams is a little rusty on the piecewise functions on the TI-80 series. I think there's a way to do it. So, but as you can see, the f of x is the mirror image across the diagonal. So we're going to save that. We'll put that, sketch that in there. But I want to show you one other thing. So we'll put the graph of that. And we'll make it kind of small. Okay? But just for curiosity's sake, and we don't have to put, and I'll come back to these notes in a second so you guys can sketch it, but just for curiosity's sake, if I remove the domain restriction, in other words, if you see a problem like this and they don't give you a domain restriction, and we said that we had a plus or minus. So if I put in the negative square root of x, and now when I hit graph, you're going to see that total mirror image, right? Does that make sense? And that's the original, that's basically this one right here, isn't it? But because they gave us the domain restriction, we have f inverse over here. Over here we have the f of x. And then in the middle we have y equals x. And that's how you double check that always. Okay? So I will leave this up here for a second or two so you guys can fit. And this is it for the notes. So we do have a couple minutes left of class. If you want to work on your assignments, you can.